Right this moment, as you watch this video, something with 4 million times the mass of our sun is devouring entire stars, just 26,000 light years away. This isn't science fiction. It's real, and it's right at the heart of the Milky Way. Sagittarius A star, the invisible monster that controls the destiny of 200 billion stars, including ours. For decades, astronomers knew something was there. Stars orbiting at absurd speeds around. Nothing, or at least, nothing we could see. A star called S2 completes an orbit around this empty point in just 16 years, reaching 3% of the speed of light. 3% of the speed of light. To put this in perspective, this star travels at more than 8,000 kilometers per second. And you know what else? In May 2022, for the first time in history, scientists managed to photograph this cosmic creature. Not a simulation, not an artistic illustration, a real photograph. 8 radio telescopes scattered across the entire planet, synchronized like a single Earth-sized telescope, worked together for years to capture the distorted light around the event horizon of Sagittarius A star. The image revealed a bright ring of superheated matter spinning around absolute darkness, exactly as Einstein's equation predicted over 100 years ago. That orange-reddish ring isn't the black hole itself, but the radiation emitted by gas and dust being accelerated to relativistic speeds, glowing with the intensity of millions of suns before disappearing forever beyond the event horizon. But here's the problem. The more we discover about this black hole, the more we realize how strange it is, and how much we depend on it. If you want to understand the most fascinating and terrifying object in our galaxy, hit that like button now and subscribe to the channel, because you're going to discover things about Sagittarius A asterisk that will completely change the way you see the universe. Let's go. Let's start with the basics. What exactly is Sagittarius A asterisk? It's a supermassive black hole, the most extreme category of black holes that exists. While stellar black holes have a few dozen times the mass of the sun, Sagittarius A asterisk has 4.3 million solar masses compressed into a region smaller than Mercury's orbit. All that mass concentrated in such a small space that it defies our understanding. The discovery of Sagittarius A asterisk is a fascinating story that began long before we had the technology to photograph it. In the 1970s, astronomers detected an intense radio source coming from the center of the galaxy. They called it Sagittarius A asterisk. The asterisk was added because scientists thought this source was interesting and exciting. Little did they know how interesting it was. For years, the evidence accumulated like pieces of a cosmic puzzle. Stars in the galactic center moved in bizarre ways, as if being controlled by something massive and invisible. In 1995, astronomers began tracking the orbit of star S2 with millimetric precision, using the world's most advanced telescopes. Year after year, observation after observation, the data fit together perfectly. There was an object with millions of solar masses occupying a tiny space. The only explanation? A supermassive black hole. But it wasn't just S2. Researchers identified dozens of stars orbiting this invisible point. Star S62, for example, passes so close to Sagittarius A asterisk that it reaches speeds of up to 8% of the speed of light. That's 24,000 kilometers per second. Imagine, in a single second, this star travels a distance greater than the complete circumference of Earth. In 2020, Andrea Ghez and Reinhard Genzel received the Nobel Prize in Physics for this monumental discovery. They proved that Sagittarius A asterisk exists. But discovering it was there was just the beginning of the journey. Because here's the truly mind-blowing part. Sagittarius A asterisk isn't just sitting there in space like an inert mass. It's active. It feeds. It breathes in a way. Every few days, telescopes detect massive bursts of X-rays and infrared radiation emanating from a region around the black hole. What's happening? Matter, gas, dust, maybe even entire stars, is being torn apart by extreme gravitational forces and heated to billions of degrees before disappearing beyond the event horizon. The process is called accretion, and it's absolutely violent. When matter approaches Sagittarius A asterisk, it doesn't fall straight in. Instead, it forms an accretion disk, a giant spiral material orbiting the black hole. Friction within this disk generates intense heat. Particles collide with each other at absurd speeds. And as matter spirals inward, It accelerates more and more, approaching the speed of light. But there's something disturbing: the size of the event horizon. The point of no return of Sagittarius A asterisk is about 24 million kilometers in diameter. That's approximately 60 times the diameter of the Sun. Sounds like a lot? It is. But compared to its mass, it's surprisingly compact. If you could somehow observe Sagittarius A asterisk up close and survive the deadly radiation, of course, you'd see a bright accretion disk, matter spiraling around a black hole at speeds close to light, glowing intensely before crossing the horizon and disappearing forever. The 2022 photo captured exactly that: a ring of orange-reddish light around a dark shadow. That shadow? It's the event horizon. It's the final boundary. Once something crosses that frontier, not even light can escape. There is no force in the universe capable of rescuing something that has crossed the event horizon. And what happens on the other side? Nobody knows. Physics, as we know, it simply stops working. Capturing this image was an impressive technical feat, the Event Horizon Telescope. The project that photographed Sagittarius A asterisk isn't a single telescope, but a network of 8 radio telescopes scattered across the globe. Using a technique called very long baseline interferometry, these telescopes function as a single Earth-sized instrument. The resolution needed to photograph Sagittarius A asterisk is equivalent to reading a newspaper in New York from Paris. Now, here's something that will blow your mind. Sagittarius A asterisk isn't alone. Practically all large galaxies have a supermassive black hole at their center. Andromeda has one with 100 million solar masses. Centaurus A has a colossus. The M87 galaxy has a giant with 6.5 billion solar masses. By the way, it was this black hole that was photographed first in 2019. It's as if supermassive black holes are essential ingredients in the recipe for a galaxy. And scientists believe they're not just passengers. They're fundamental to the formation and evolution of galaxies. The data shows an impressive correlation. The larger the galaxy, the larger the black hole at its center. It's not a coincidence. Somehow, the growth of the black hole and the growth of the galaxy are intimately connected, intertwined in a cosmic dance that lasts billions of years. The black hole regulates star formation through galactic winds and jets of matter. When Sagittarius A asterisk feeds vigorously, it can expel matter and energy back into space, heating the galaxy's gas and preventing it from collapsing to form new stars. It shapes the structure of the galaxy through its immense gravity, keeping stars in stable orbits and influencing the distribution of matter throughout the Milky Way. Some supermassive black holes. We don't yet know if Sagittarius A asterisk actively does this at the moment. Launch jets of matter and radiation that extend for millions of light years into space, the so-called relativistic jets. These jets travel at 99.9% of the speed of light and carry energy equivalent to trillions of supernovas. If Sagittarius A asterisk decided to turn on its jets at maximum power and point one in our direction, well, let's just say we wouldn't be here to tell the story. But relax. Sagittarius A asterisk is relatively calm by supermassive black hole standards. It feeds slowly, chewing matter bit by bit. Compared to quasars, hyperactive supermassive black holes that shine brighter than entire galaxies, our central black hole is almost well-behaved, almost dormant. Still, things get crazy there. In 2019, astronomers observed Sagittarius A asterisk become 75 times brighter than normal within a matter of hours. Something massive, possibly a cloud of gas the size of our solar system, or even a giant asteroid, was torn apart by tidal forces and devoured. The resulting burst of radiation was detected by telescopes around the world. And then, as quickly as it started, it ended. The black hole returned to its normal state, as if nothing had happened. Here's something few people know. Space-time around Sagittarius A asterisk is so distorted that time literally passes more slowly there. This is the effect of gravitational time dilation predicted by Einstein's general relativity. If you could survive near the event horizon, 1 year for you would equal decades or even centuries for someone on Earth. Gravitation and time are intertwined in ways we're still trying to fully comprehend. But perhaps the most fascinating aspect of Sagittarius A asterisk is what it teaches us about fundamental physics. The black hole is a natural laboratory for testing the most extreme theories of physics. Near the event horizon, gravity is so intense that relativistic effects completely dominate. The orbit of star S2, for example, doesn't follow a perfect ellipse as Newton's laws would predict. Instead, it precesses. The ellipse slowly rotates over time, exactly as general relativity predicts. In 2018, when S2 passed through its closest point to Sagittarius A asterisk, astronomers detected gravitational redshift. The star's light was stretched to longer wavelengths by the black hole's intense gravity, exactly as Einstein predicted. It was another brilliant confirmation that general relativity works even under the most extreme conditions. The truth is that each answer about Sagittarius A asterisk generates 10 new questions. How did it form? Was it there before the stars of the Milky Way, serving as a gravitational seat around which the galaxy formed? Or did it grow along with the galaxy, devouring matter over billions of years, starting as a stellar black hole and gradually growing to its current mass? The data suggests both possibilities, and scientists are still debating intensely. One theory suggests that Sagittarius A asterisk formed from the direct collapse of a massive cloud of gas in the early universe, over 13 billion years ago. Another theory proposes that it started as a normal stellar black hole and grew over eons through the accretion of matter and mergers with other black holes. The truth probably involves elements of both theories. And there's more. What happens inside a black hole? Once matter crosses the event horizon, it's compressed toward the singularity, a point of infinite density where all laws of physics collapse. Or does it? Some physicists believe that quantum mechanics might prevent the formation of a true singularity, creating something even stranger, a region where space and time mix in unimaginable ways. Stephen Hawking proposed that black holes aren't completely black. They emit radiation through quantum effects near the event horizon. This Hawking radiation would cause black holes to eventually evaporate over incomprehensibly long periods of time. What we know for certain is this: Sagittarius A asterisk is there, silent, patient, immortal. It witnessed the galaxy's birth and will witness its death. It will outlive the sun, Earth, every star you've ever seen in the night sky. And for trillions of years after the last star goes out, when the universe is a cold and dark place, Sagittarius A asterisk will still be there, in absolute darkness, waiting. It witnessed the formation of the first planetary systems. It saw countless potential civilizations arise and disappear. It observed billions of years of cosmic evolution, and it will continue observing for eons after our existence has become less than dust. But the story doesn't end here, because there's another black hole, bigger, more violent, and it's coming our way. In approximately 4 billion years, when the Milky Way collides with the Andromeda Galaxy in a spectacular galactic merger, Sagittarius A asterisk will come face to face with Andromeda's supermassive black hole, a giant with over 100 million solar masses. And when two supermassive black holes collide, the universe literally trembles. The merger generates gravitational waves so powerful, they distort the very fabric of space-time, ripples that travel through the cosmos at the speed of light. The event would release more energy in a few seconds than all the stars in the observable universe emit in a year. What will happen in this cosmic encounter? What will it be like to witness this final dance between two gravitational titans? They will orbit each other for millions of years, losing energy through gravitational wave radiation, spiraling closer and closer until they merge into a single, even larger black hole. And what does this mean for the future of our galaxy? Or rather, of the resulting galaxy that scientists have already nicknamed Milkdromeda? Leave in the comments. Would you have the courage to get close to Sagittarius A asterisk if you could, knowing it's a one-way trip? And which aspect of this black hole do you find most fascinating? The time distortion, the extreme temperatures, or the mystery of what exists beyond the event horizon? Share this video with that person who loves astronomy and subscribe to the channel and turn on notifications because there's much more incredible content coming. See you next time.